PNL Sigma Interpretation. This video demonstrates the typical workflow for the interpretation of Sigma logs. PNL data are loaded. The tool may produce more than one Sigma formation curve. Ensure the relevant curves are identified. As with any cased whole log, it may be necessary to apply editing options like filtering. In this case, the log is depth correlated against the open hole gamma ray. Once the data is ready for analysis, an interpretation is created by clicking on the Information button. The interpretation type is kept as Sigma. Based on the open hole logs, the adequate petrophysical model is defined. In this case, Shaley single water is selected. The required interpretation inputs are as follows. The Sigma formation is the PNL measurement that will be used to compute the water saturation. The correct source of Sigma formation must be selected. For effective porosity and V-shale, open hole logs are selected, typically located under the General Well Data node. The Sigma matrix can be based on the formation lithology. A table with different minerals is available for reference. The default value is kept for now. The calculation of Sigma hydrocarbon uses correlations based on the PVT properties. There are specific models for oil, gas, and condensate. Calculate is selected to compute Sigma hydrocarbon. Similarly, the Sigma water is based on a correlation to the salinity. The Sigma shale value is by default the maximum Sigma recorded in the measurements. To refine the definition of the Sigma components, Emeraude uses various crossplots. First, PNL zones are defined from which the data will be selected. A PNL zone should encompass intervals with constant Sigma components. Define as many zones as there are different lithologies or formation fluids observable in the logged interval. Click on Sigma. The default crossplot shows the measured Sigma versus the effective porosity. At 0% porosity, the Sigma is equal to the one of the matrix. At 100% porosity, Sigma can be the one of the water or the hydrocarbon. This defines two lines for water wet and hydrocarbon wet formation. All the data points should fall in between these lines. The endpoints can be modified interactively by shifting them up and down. Their value can also be typed in. After any Sigma component is modified, the Sigma envelope track is updated. This shows the Sigma for the water wet and the hydrocarbon wet formations together with the measured sigma. The measurement should stay between the two endpoint curves. The sigma matrix of both zones is modified to better adjust the data. In the All Results table, the sigma components for all zones can be seen and edited. The results of a sigma interpretation include a calculated water saturation track, the pore volume analysis, and the bulk volume analysis. If historic water saturation curves are available, it is possible to create a time-lapse view. In this case, the open hole water saturation is displayed together with the PNL saturation in the pore volume analysis track. This facilitates the detection of flooded and unwept intervals. This concludes this video on PNL sigma interpretation.